Hello everyone, how's it going? Vasco here. In this lesson we are going to finish the implementation of the send new message reducer, and we are going to see how can we scroll the list of messages automatically to the bottom of the list each time that we add a new message. So let's see how can we implement that. So let's start by the current participant ID. We're going to add here a new member variable to the send new message payload. We're going to call it the participant ID. So this is the person that typed in the message. This also will be a number. Now if we go back to message section component, now we have here a compilation error. To fix this we need to retrieve the current user ID from the store. Now at this point we would be retrieving the whole UI state from the store basically. So it's simpler to simply create a snapshot of the UI state and assign it here to a member variable. So let's see how we can do that. So now we simply populate this member variable like this. So we store the whole UI state. Actually, whenever we retrieve this, we need to be careful not to modify it. So if we would modify it, we would be modifying it inside the store. We really want to avoid this. So a good way to prevent that problem is, if we need the UI state, let's simply create a copy of it. So we will create here an empty object and we are going to populate it with the state UI state. So this way we have created a copy of the UI state, and whatever we would do here in this smart component, the message section smart component, we wouldn't be modifying the state inside the store. So now how do we fill this in? We are going to use the UI state member variable to pass in the current thread ID, and we are also going to fill in the participant ID with the current user that is selected. So now that we have added this extra bit of functionality to send new message action, we can go here and implement another property that we previously did not have a value for, which is the participant ID. We can take this again from the action payload. Now the only property that is missing is the ID property. We need this to be a unique identifier. So if our backend would be Firebase, we would be able to generate here an identifier without making a server call. We could define it here synchronously on the client side. For this particular application, we simply need the identifier to be unique. So we won't be using it anywhere else in this chat room. For that, let's install here a new library. Let's install here a library that allows us to generate unique identifiers. It's called UUID. We will install it as a normal development dependency. And once the installation is completed, we can use the library in the following way. We are going to do a simple CommonJS import. We are going to call it UUID, and we are going to require the latest version of UUID. So UUID v4. Now that we have here UUID available, let's generate a unique identifier using it like this. So we have generated a unique identifier on the client side. We have here a new message. Now what we're going to do is we are going to first link the message to the thread. So we're going to do current thread, message IDs, and we are going to push into this message IDs array. We are going to push the ID of the new message. So that is the first step, linking the thread and the message. The second step is to go to the state and actually save the message. So in state.messages, we are going to create a message and we're going to put it under the key of new message.id, and the value will be the new message itself. Now at this stage we might think that we have here a correctly implemented reducer function. This is a good example of how it's very easy to write the reducer functions in a way that introduces bugs that are hard to troubleshoot. This function has two problems here. The first big problem is the use of object assign to clone the store state. So the problem with object.assign is that it does not do a deep copy of the state. So if some of the properties of the object that we are cloning are objects, it will copy the references to those objects. So the new store state here would have references to objects inside the store, to the previous version of the state. So the first thing that we will do is we are going to use a Lodash utility to do a deep clone of the state. So this solves the first problem in this code. There's a second problem here, which is we are mutating the state directly. Did you notice it? We really want to be sure that we are only accessing the new store state. So in this case, for example, it wouldn't make a difference because it's a read operation. But for example, take a look here. Here we were modifying the state actually, so it's very easy to fall into this situation. We're going to see how the use of immutability would help us prevent this situation from occurring. Mutating the store state directly tends to create bugs that are very hard to troubleshoot and really break the whole store solution. So this is really something to bear in mind. So with this, we have created a new message and we have saved it into the store. We have not yet sent the request to save the message on the backend, but right now we should already see the new message on the screen. So let's try it out. If we head over to our application and we lower the thread, for example this one between Alice and Bob, let's scroll to the end. Let's say hello Bob. If we hit enter, we can see here that the slider moved, and if we scroll down we are going to see the new message on the screen as expected. Now we would like to quickly add the functionality of whenever a new message is available to scroll to the bottom. So let's do that.